Okay. Effect of pressure in real life. Yesterday we saw what is pressure, okay, and what is the effect of it. Now, pressure also has effect in our real life, such as it helps us to cut fruits and vegetables easily with a sharp knife. When we apply pressure on them, we are able to cut them easily. Then schools and carry bags, they have a wide surface to carry more items. Labor and coolie wrap cloths on their head to make their work easy. Okay, so these are the examples of pressure, of the effect of pressure in our daily lives. Now, there is one more type of pressure called atmospheric pressure. Imagine you have cotton in your hand and you make a small round of it. The quantity of cotton is same, but it has now shrunk. If you have this much cotton, we roll it and make a ball out of it. Okay, the quantity will remain the same, but the size will become less. Okay, it will shrink. In the same way, the air around you gets pressurized from the air above it. This pressure of air is known as air pressure. Okay, when the air around us is pressurized, when the air around us is pressurized, it is known as air pressure. Okay, air pressure. There is activity. Take a box of thin tin, thin tin. Fill it with some water. Boil it in such a way that both air and steam get out of it. Now close the box and put cold water above it. What happens? Box will get stick from all the sides. Why? Because the hot air inside the box comes out of the box and it is replaced by water steam. This is changed to water at the time of cooling and reduces air pressure. The air outside exerts more pressure on the box from all sides, which makes the box stick. Okay, that is air pressure. Then there is pressure by liquids. Liquids also exert pressure. When you immerse yourself in water, then the pressure which is exerted by water is heard by the ears. This force is pressure. Okay, if you have while swimming, you have put your whole face and ears under the water, you can hear the sound, right? You can hear the sound. So that sound is like pressure. Okay, we can hear it. That is the pressure exerted. Okay, which we can hear. It is found in all liquids and gases. Gases and liquids together are called liquids. Okay, we say solids and liquids. Under the category of liquid comes liquids, that is those things which are in liquid form, and the gases both. Okay, these liquid items exerted pressure in all directions, up, below, and equal, but this pressure is directly proportional to the depth of liquid substances. Okay, to the depth of liquid substances. Means that the pressure which it will exert is like this. Okay, up to bottom. Okay, and it also depends on the depth of the water. Okay, the depth of the liquid. If it is very deep, okay, the deeper the pressure will be more. Take a pipe of transparent glass or plastic pipe around 15 centimeter length. Take a sheet of good and thin rubber. You can also use the rubber of balloon. Now cover the end of the pipe with rubber sheet. Hold the pipe from center in vertical shape. Ask your friend to insert some water in the pipe. Does the rubber sheet bloom in the outer corner? Note down the height of water in the pipe. Now put some more water in the pipe. Note down the rise in the rubber sheet and the height of water in the pipe. Repeat this height procedure. Do you find any relation between blooming of rubber sheet and height of water? The more water you put in the tube, okay, the more the rubber sheet will bloom. Okay, the less water, the less it will bloom. The more increase in water you put, the more the rubber sheet will bloom. Okay, then there is an activity. Take a plastic bottle. You can also use used water cold drink bottle. Heat an end of 5.6 centimeter long glass pipe and place it in the bottom of bottle. Check that water should not leak from the ends. If this happens, insert wax at the leak point. Close the mouth of the glass pipe with a thin rubber sheet. Now fill half bottle with water. What do you find? You will find that the rubber sheet in the mouth of glass pipe, it blooms. Now put some more water in the bottle. Okay, do you find the difference in blooming of rubber sheet? Observe that the rubber sheet is placed in the walls of bottle, not in the bottom of bottle. Thus, the blooming of rubber shows that water exerts pressure on the walls of utensils. Okay, see, the a glass tube is there. Okay, and when we fill water inside it, okay, and rubber sheet is there, so this end and this end will bloom. Okay, means that the liquids they exert pressure on the sides of the utensil. This is the side of the tube. Okay, so on the sides of the utensil, if you have a utensil and you have water in it, okay, the pressure will be on the sides of it. The pressure that will be exerted will be on the sides of it, okay, on the walls of the utensil. Now, does gas exert pressure on the walls of utensils in which they are kept? When you have blown a balloon, why its mouth is closed in order to see that the air does not get away. If this mouth opens, what will happen? Imagine you have a balloon having a hole. Can you blow it? No, because air pressurizes every direction. Okay, if there is a puncture in the cycle, what happens to the air inside it? These examples show that air pressurizes the walls of tubes of tires in cycle or balloon. Thus, we can say that gas exerts pressure on the walls of utensils in which it is kept. Gas also, okay. Liquid and gas, both of them, they exert pressure on the walls of the utensils they are kept in, okay, or on the walls of the things that they are inside of, okay. Let's try out in text questions 15.5. Take the correct statement and cross around. There is different pressure in different directions at a particular depth in water. I think it's the same pressure. Yes, so this is false because it is the same pressure. Okay, this is false because the same pressure is there. Okay, because see, why the same pressure? Okay, not a different, but the same pressure is there in different directions at a particular depth because the depth is the same. Okay, the depth is the same. Okay, at one particular depth in different directions there will be same amount of pressure, but if the depth is changed, okay, then the pressure will change according to the depth. Okay, the pressure will change according to the depth, and but still the pressure in different directions will be the same. Then pressure increases with depth in liquid. True or false? Yes, Emma.
Ma'am, can you repeat? I can't hear you.
Yes, Emma. Pressure increases with depth in liquid. Is that true or false?
Ma'am, true.
Yes, it is true. Liquid exerts pressure on the walls of utensils. True or false? True. Okay. Now, can you give reason why water tanks are kept a little above the ground? Now, why are water tanks kept a little above the ground is because it uses like gravity so that it can use gravity to create pressure which drives the water flow to the taps and fixtures in the household. Okay, so that it can use the gravity to create pressure which drives the water flow to taps in the household. Okay, this is why the water tanks are kept a little above the ground. As you go up from Earth, what are the changes in atmospheric pressure? What are the changes in the atmospheric pressure? Atmospheric pressure decreases. Okay. As we go up from the Earth, the atmospheric pressure decreases. Okay. Because there is less air above us and it results in less air molecules. And because the density of air is lower at high places when we go up from the Earth. Okay. With this, we have finished with this lesson. Hello, Ibrahim. Okay. Can you do match the column? Linear motion. Yes, what is a linear motion in this? The real motion. Okay. Then what is the circular motion? Abraham, which one is the circular motion? Hello, can you hear me? Both of you?
And please repeat you keep breaking.
My
And you
voice.
keep breaking. Can you?
Okay. Circular motion is the motion movement of clock. Okay. Cylindrical motion is a rotation of sun by the earth. Ball bearing is a technique of less friction force. Items kept on table is in static position, and moving car can be stage of motion. Okay. Fill in the blanks. Dash makes changes in the shape of objects. Dash makes changes in the shape of objects. Force. The force exerted on top level between the surfaces is known as the force exerted on top level between the surfaces is known as yes, Abraham Emma. Friction force. To dash friction force, design are made in tires. To increase friction. The ratio between dash and dash is known as pressure. The ratio between dash and dash is known as pressure. Force and surface area. Force and area. Take the correct statement, cross the wrong statement. Items exerting pressure on horizontal in various stages is known as pressure. By sharpening knife decrease the area of its surface, it's true. Pressure exerted on any base is in ratio to length and also has heterogeneous ratio. Its area, true. The pressure on the base of utensil depends on the height of liquid filled in it. True. Okay. And the pressure on the base of utensil, it's not on the base of utensils, but on the walls of utensils. What is the importance of friction force in your day-to-day life? Explain with example. Can you give the importance of friction force?
Yes, ma'am.
Yes,
Friction
what?
is not important as it lets us walk. It lets us erase what you call that? Erase stuff from the from our paper. Friction also helps us to like when we are playing toys. Most of the toys, like about 90% toys that we play with, use friction to work,
Hmm.
such as bricks or even everyday in everyday life, everything we use mostly uses friction.
Correct, Abraham, that is right. Now, take the correct option. The SI measurement of length is, what is the SI measurement of length?
The SI unit of length is kilogram. No, wait, meter.
Yes, Abraham, it is meter. Force makes things in motion, stops things in motion, changes the shape of things in motion, or all of the above.
I'm all of the above.
And all of them.
The force opposing the motion of an atom is known as?
I think friction first, right?
Force.
Friction force. Friction force. Show how pressure is equal in all directions. This is the activity. Okay. Pressure is equal in all directions. Okay. The pressure is equal in all directions. The only thing that um, affects it, okay, is your if it's like if you're talking about liquids and gases, the only thing that affects it is the depth of the liquids. Okay, the depth of the liquids that affects it. Okay. Now, when a dropper nozzle is pressed after keeping in water, many water bubbles are spotted. If pressure is removed from valve of dropper nozzle, water gets spilled. The reason of water moving in dropper is,
When pressure is equal in all directions, when you draw a force diagram now, you have the same amount of, for a stationary object, you have the same amount of gravity for the same amount of normal force. You have the same amount of friction, the thing is moving, for the same amount of force that is applied.
hmm, now what will be the answer to the seventh question?
Human. The ma'am, pressure, atmospheric pressure.
Atmospheric pressure.
Because ma'am, when you remove all the air from the drop of water, you create a I think pressure on the top. I'm not sure which high or low. And because of the atmospheric pressure, the dropper sucks the water into it.
The dropper. Can you
I'm
repeat
asking
it?
to create low pressure.
Okay. Yes. Now I can hear. Yes, Abraham. The correct answer is the atmospheric pressure. Okay. It is due to atmospheric pressure. So with this, we have finished with the lesson. With this, we have finished with the lesson 15. And tomorrow, I'll see if I can do a worksheet with you in science. Okay. Or some exercises related to force, some case-based questions and all that we can try tomorrow. And then Friday is your quiz. Okay, Friday is maths quiz, right? Not science. So once we've tried that out, we'll start a new chapter in science. Okay. Then Friday is your maths quiz. So please prepare. Please prepare from the exercise that I've told you about.
Yes, ma'am.
Okay. Okay. 5 minutes break for all, and then we will start with maths. Let's begin. Hi Joshua, good morning.
Hi, ma'am. Good morning, ma'am.
Good morning. Hi Abraham, Emma, turn on your videos. Okay, now today I will teach you the concept of compound interest. Okay, compound interest. Now, previously, the concept that we studied was simple interest. Okay, this time we will study compound interest. See, the interest is the same thing. Okay, only compound interest. The difference is that, see, suppose I have my principal amount for first year. First year, I have to calculate my interest. Principal is 100. Okay, rate is 10%. Time is 1 year. Okay, so calculate my interest. Interest is equals to P into R into T upon 100. On 100. Okay, so 100 into 10 into 1 upon 10. Sorry, into 1 upon 100. So cancel. Interest is 10 rupees. Okay, 10 rupees. Now for the second year, if I have to calculate, the compound interest for 5 years. Then I'll calculate for the second year. I will not calculate, okay, this is my principal, this is my rate, and this is my time. Okay, I will not calculate it for 100. Like principal, I will not take 100. Okay, principal for the second year will be 100 plus interest of the first year plus 10 equals to 110. Now with this 110, I will calculate 110 into 10 into 1 upon 100. Cancel the zeros. 11 rupees. Okay, 11 rupees. Then for the third year, I have to calculate interest. So my principal will not be 110. Okay, my principal will not be 110. It will be 110 plus 11. Okay, 110 plus 11 into 10 into 1 divided by 100. Okay, so we will do principal will become 110 plus 11. That is, this interest will be added here. Okay, this interest is added here. This interest is then added next. So 121 into 10 into 100 divided by 100. Oh, sorry, into 10 into 1 divided by 100. Cancel 0 with 0. How much I will get? 12.10. 12.10 rupees. Okay, so this is my interest. Okay, this is known as compound interest. Compound interest, where your principal amount is not same. Okay, but every year we take the principal. Okay, every year we take the principal of the previous principal and add the interest of previous year, and then the new principal that will be calculated on that we calculate interest. Okay, then this is the second year. Then third year, what I did? In the third year, what I did? I took the principal of the second year, and in that I added the interest of second year. And on that total amount, which is 121, with that total amount, I calculated interest for third year. If I calculate interest for fourth year, I will take the principal for third year, that is 121. In that, I will add the interest of third year, that is 12.10. So I will do 121 plus 12.10. Okay. And in that, on that amount, I will calculate the interest for the fourth year. So when you do like this whole process is known as compounding. Okay, this whole process is known as compounding. Okay, write this down. Write this down, compounding. Understood, Joshua?
Not that much.
Not that much. Okay, it's okay. Okay. See, if your mama is giving you every month 10 rupees, okay? Every month she's giving you 10 rupees to eat chocolate, okay? You ate chocolate of 8 rupees. You ate chocolate of 8 rupees, okay? You ate the chocolate for 8 rupees, and the remaining 2 rupees you gave to your mama, okay? Remaining 2 rupees you gave to your mama. Next month, what your mama did? She gave you 10 more along with the 2. Okay, so she gave you 12 rupees. Okay, then out of this 12 rupees, the next month you went and eat chocolate of 10 rupees. Okay, 2 rupees were left again. Or you say next month you went and ate chocolate of 8 rupees again. 8 rupees again. Okay, so how much will be left? 4 rupees. After that, the next month, your mama will give you how much? How much? 14 rupees
Yeah.
or 12 rupees. Okay, so this is known as compounding. Okay, means the previous one is added back. The previous one is added back. This is what we're doing, Joshua. This is almost what we are doing here. Okay, like see the principal rate and time. I calculated the interest of first year. This I taught you already. How to calculate P into R into T upon 100. Okay, rupees 10. Okay, then second year, you will, in this 100, you will add this 10 of the previous month. In this 100, you will add this 10 of the previous month, and then using 110, you calculate. Okay, using 110, you calculate. Then comes your third year, Joshua. In your third year, what you do? In 110, in this 110, you take 110 from you, and in that 110, you add this 11 rupees. This 11 rupees of the previous year. So it becomes how much? Becomes how much? It becomes 121. Okay. It becomes 121. So on this 121, you will calculate the interest. We keep adding the previous interest to the previous principal. Okay. To find out the compound interest. Now, because this process is very long, we have a formula. Okay. First, you write this down. First, you write this down, and then I'll teach you one formula to do this process. The one in the box is your interest. This process, when you add the previous one, is known as compounding. Okay, simple interest, principal remains the same, principal amount remains the same every time. Okay, every time the principal amount remains the same, but in compound interest, we take the previous year's principal and add the previous year's interest in that. And on that, we calculate the interest for the present year. Okay,
Done, ma'am.
done. Okay. Abraham and Emma, you all got it?
Yeah, mom, I kind of got it.
Okay.
Ma'am, I understand.
Okay. Now what we will do is that I will show you one table. Okay. I'll show you one table of comparison. Give me a minute. Now, if you can see in this table, if you can see in the table, principal, okay, is 100 in both the cases. The first principal is 100. Okay, this is my principal. Okay, in simple interest, first year principal 100, second year principal 100, and third year principal is also 100 in simple interest. Okay, how interest is calculated? PRT by 100. Okay, so 1110 in simple and compound interest first year you will get the same 1110 and 1110. Okay, this is a 10 and 10 rupees interest you will get. Same interest you will get. How it is calculated? PRT by 100. Okay, then the second year. Look, second year principal and simple interest is 100, but compound interest it becomes 110. How? How? I took the previous year's amount, okay, and I added the interest in it. Okay, I took the previous year principal plus previous year interest and it became 110. This is my new principal. Okay, this is my new principal. So when on 110 you will calculate, you will get how much interest? 11. This is my interest, 11. We just did this, right? This compound interest column I just solved with you. Okay, so 111 we will get. Okay, then we will, in the previous year principal, you will add the previous year interest, 121. This is your new principal. 121 is your new principal. Okay. Now on 121, you will calculate interest. Okay. By 10%, you will get 12.10. Okay. 12.10, which is your interest. Okay. So if you add 10, 11, 10 plus 11 plus 12.10, you will get how much? 133.10. This is the total interest. Oh, sorry, 33.10. Okay. Your interest, 33.10. Okay. Whereas here, if you add your interest, third year also 10 you are receiving his interest. Okay. Second year also 10 only you will receive it as interest. First year also 10 rupees only you will receive as interest. So here interest is how much? Here interest amount is how much? Only 30 rupees. Whereas here 33.10 rupees. Okay. Now which will give you more money? Which is more profitable? Compound interest is more profitable. Okay, compound interest always gives you more money. Okay, why is that? Because in simple interest the principal is always the same every year, same principal, same rate, same everything. But in compound interest every year the principal increases. The principal increases. Okay, how? I show you here. Okay, I showed you here how the principal increases. Okay, first year it was 100. and interest was 10 rupee. Second year principal will become 100 plus the interest of previous year, that is 110. Second year, you will not calculate on 100. Simple interest you will calculate on 100. Compound interest you will calculate on 110. Compound interest you will calculate on 110. Principal increased. Okay. Third year, simple interest you are calculating on 100 again. Compound interest in previous 110, add the interest of the previous year 11. 121. On 121 you are calculating. See, here only on 100 you are calculating. Here you are calculating on 121. So more interest. Okay. More interest, more profit. So compound interest is always more profitable. Okay. Compound interest will generate more money. More money, and compound interest is always the bigger amount. Okay. Compound interest is always bigger than simple interest. Understood now?
Yes, ma'am.
Understood?
A bit, ma'am.
Okay. But still a bit, right? Like the principal, how the principal increases every year. Okay. The
Yes.
previous interest adds to it. The principal increases every year. So at the end, in compound interest, you will have more money compared to the simple interest. Okay. Compound interest, you will have more money compared to the simple interest. Now see, I told you all that this in compound interest, we calculate the principal, okay, the previous interest and principal is added to the next principal, okay, to make it the next principal. Now this adding process is known as compounding, okay. This adding process is known as compounding, and it is done in 3 time periods. It is done in 3 time periods. Some people do this compounding every 3 months. Every 3 months. Some people do compounding every 6 months, and some people do compounding once in a year. That is known as yearly. Okay, I'll explain you that concept. So this screenshot I will share. Okay, this table screenshot I will share in the group. Okay. I will teach you now the time periods under the compound interest. Okay. Now, compound interest or compounding is done in 3 time periods. Compound interest is calculated in 3 time periods. Okay. Three months. 3 months. Every 3 months. Okay. Then every 6 months and in a year. Okay, in a year. So when you do compounding or when you calculate compound interest in every 3 months, it is known as quarterly. Quarterly. When you do in every 6 months, okay, every year has how many months? 12 months. Okay, every year is how many months? 12 months. So half of every year. Half of every year is 6 months. 6 months and 6 months. Okay. So in 6 months, you do it 2 times. 6 months and 6 months, 2 times. Okay. So this is known as half yearly because 6 months is half year. So half yearly. Then in a year means only one a year. This is known as annually. Annually. Okay. Annually or annual. Now, for this compound interest, we have a formula. Okay. And in compound interest, two things are calculated. In compound interest, there are two things that are calculated. Okay. two things that are calculated. The first thing is calculated the amount. The amount. Okay. And the second thing that is calculated is the compound interest. Second thing that is calculated is the compound interest. What is amount? What is amount? Remember I explained you in the when I was telling you the meaning. Okay, look here, Joshua. Look here. Explain. Remember when I was teaching you interest, I taught you what is amount. Okay, principal plus interest. Okay, that is amount. I told you all about it. So amount we are calculating first and then compound interest. To find out the compound interest, these two things are calculated. Okay, we will see.
What? Sorry, ma'am.
We will see the formula. Okay, we will see the formula for amount. Okay, now 3 months. Okay, in 3 months, 3 months is how many part of the year? Okay, see, I have um okay, I'll make it here and show you. So 3 months. Okay, this is your first month, second month, third month, fourth month, fifth month. Okay, sixth month, seventh month, eighth month, ninth month, and 10th month, 11th month, and 12th month. 12 months are there. Okay, every 3 months compounding is done. Means that from here to here compounding is done. From January to March. Okay, till March compounding is done. Then the compounding is done from here to here, 4, 5, 6, then 7, 8, 9, then 7, 8, 9, and then 10, 11, 12. Okay, so this 3 months, 3 months, 3 months, and 3 months. Every year has a 3 months part. How many? 4 parts. Okay, every year is divided into 3 months in how many parts? 4 parts. Okay, these in Roman numbers that I've written is 12 months. Okay, then 3 months part is there in every year. Okay, 3 month part is there in every year. Okay, so that gives me the formula. That gives me the formula. 1 minute.
Ma'am,
Yes, Joshua.
for me, I now right now lost the whiteboard. I can't see
You
the
lost,
whiteboard, ma'am.
you lost the whiteboard.
Yes, ma'am.
Abraham and Emma, can you all see the whiteboard?
Yes, ma'am, I still can see the white.
Ma'am,
Okay.
look for me.
Okay. Joshua, can you like close and come back?
Okay, ma'am.
Okay. Okay. Joshua, can you see now?
Yes, ma'am. Now I can see, ma'am.
Now you can see. Okay. So I was telling you all the formula. Okay, first two things are calculated. Okay, two things are calculated. First thing is the amount. So amount formula is A is equals to P 1 plus R upon 100 raised to the power 4n. Okay, raised to the power 4n. Why 4n? Why 4n? Is because there are four parts. Okay, there are four parts in my ear. Okay, 1 minute. Okay, and then half yearly or 6 months we have half yearly or 6 months we have. What will be the formula for 6 months? Okay, one more. Yes, one more thing. The rate will be divided by 4. Okay, the rate will be divided by 4 because there are four parts in quarterly. In quarterly, there are four parts. The year is divided into four parts. Rate will be divided by 4. Okay. In 6 months, amount is equals to principal 1 plus. Now see for 6 months. Okay. See for 6 months. From here it starts. From here it starts and here 6 months, 6 months, and from here it starts until here 6 months. So how many 6 month, 6 month periods are there? Two. Okay, two 6 month and 6 month periods are there in a year. So rate R by 2, rate divided by 2 upon 100 raised to the power 2n. Okay, raised to the power 2n. Then annually is only 1. So amount is equals to principal 1 plus R upon 100 raised to the power n. Only n. Okay, because 1 year only 1 is there. In a year only 1 is there. Okay, so only n. Understood? Then see, if do you want to write down this dividation of year, it's not important, but it was for your understanding. This portion. This portion is only for your understanding. Okay, so I'm clearing it. I'm clearing it. If you want to write down, you can write how 1 year is divided into three months, and how 1 year is divided into 6 months and 6 months.
Ma'am,
You
I'm
want
going
to
to write it, ma'am.
okay, write it.
Done, ma'am.
Okay. Now, so this is the step 1. Okay. This is a step 1. We calculate A. A means amount. Okay. We calculate the A. A means amount in all the 3. Okay. A is amount. I'll write it for you here. Okay. A is amount. A refers to amount. R, P refers to principal. R is rate. N is time period. Okay. In this formula, P refers to principal, R is the rate, N is the time period, and A is the amount. This step we do in all 3. If we have to find quarterly, means every 3 months. If we have to find half yearly, means every 6 months. And when we have to find yearly, means complete year. Okay, the formula is same. One thing that changes is rate. If you are finding quarterly, we divide rate by 4, R by 4, and 4n. We multiply. See, 2 years I have to find quarterly, so 4 into 2 I will do. Okay, 4 into 2. That is 2 is my number of years. Okay, then here in half yearly, rate will be divided by 2 because in 1 year I have 2 parts of 6 years and 6 months and 6 months. So R by 2 and outside 2n. And here, no, nothing. Rate will be as it is and n will only be there because annually means only 1. So this is the formula. This is your step 1. Okay. This is your step 1. Okay. Then we will see the next step. We will see the next step. Next step is the same for all 3. Okay. Next step is the same for all 3. We calculate compound interest. We calculate compound interest. Compound interest is equals to A minus B. Compound interest is equals to A minus B. Compound interest is equals to A minus B. Same thing. Okay. Same thing you have to do. So A minus B, here what is my A? CI refers to compound interest. Okay. After this step, you will do this step. After this step, you will do this. And after this step, you will do this step. Okay. A CI means compound interest. CI means compound interest. Compound interest. A is amount and P
Principal.
is principal. Okay. So this is step 1. Okay. Hashtag 1 I'm writing. And this is hashtag 2. Step 2. Okay. Step 1 and step 2. First you find amount, then you find compound interest. Okay. 3 time periods are there. 3 months, 6 months, 1 year. 1 year is the easiest. 3 months is a little hard. Okay, but not very hard. We will do the questions and we will understand how. Okay, but this is the concept of compound interest. Now copy this whole thing. Write it down in this form, chart format. Make a chart and write this down.
Good, ma'am. Done, ma'am.
Okay. Abraham and Emma also done?
Mama, kind of.
Kind of. Joshua, did you understand little bit?
Yes, ma'am.
Okay. When we do the questions, it will become more clear.
Ma'am, we can do a question like this in 6 minutes.
We can do a question like this in 6 minutes. We can try. Okay. We can try some small question. Or we can do it tomorrow.
Because ma'am, question like this is not small, it's big for me.
That is true, Joshua. Question like this is not actually small, it is a little big. Okay? True. We will do question tomorrow. Okay, just let me know if you've written this nicely. If you have written this nicely. Okay. What happened, Abraham?
I think that was my mistake.
Okay.
Ma'am,
Yes.
I have a question.
Mm-hmm.
Yesterday you had told that Abraham should not join this class. He should go to a different class at 10.
Abraham, that was for yesterday, Joshua. Yesterday, Abraham had an extra class with his class and one more class. Okay.
Okay, ma'am.
Because he was having some doubt in an exam, so that is why we took extra class for Abraham and explained him some topics. That is like done already. Okay.
Ma'am. Thank you, ma'am.
How was the maths paper, Abraham?
The maths paper was easy, man. It was just a little bit difficult in the, not difficult, but I was not able to complete like the 4096 took the most longest.
Okay. Factorization.
Yes, ma'am.
Hmm.
And then no factorization came like of algebraic expressions.
Yeah. Hmm. Maybe next time they will come. Okay. So written done writing. All of you. Okay. So we will stop here for today. Tomorrow we will do the questions of compound interest. Okay. We will do the questions of compound interest. Today, you guys please complete 9.1 simple interest exercise. Okay. Please complete 9.1. If there are any doubts in 9.1, I will take tomorrow. Okay. Any doubts in 9.1, I will take tomorrow. Okay. Or Monday. But please finish it. Finish the questions of 9.1. Okay. So that's all for today. Have a good day. See you all tomorrow. Bye.